Let's graph a transformed sine wave. So what I'm going to do is put a function that's a sine function on the screen, and we're going to see if we can graph it. So to do that, I'm first going to get rid of this title so I have more room to write. And the function I want to graph today is f of x equals 3 sine 2x minus pi plus 1. So I have all four things going on in this function. I have coefficients in four different places: the 3, the 2, the minus pi, and the plus 1. The first thing I want to do is jot down some of the key features of this wave. And the first one I'm going to jot down is the midline. And the midline for this sine wave is y equals 1. And the reason why that is because of that plus 1 right there. Typically a sine wave has a midline right along the x-axis, but this sine wave will have its midline up at y equals 1. Next I'm going to jot down the amplitude. And the amplitude is 3. And the reason why it's 3, as you might guess, is because of that coefficient in front. Typically a sine wave has an amplitude of 1. It sort of moves like that. But this sine wave will have an amplitude of 3. It will go up much higher and end up much lower. Alright, there are two other items that we have to note, and those are the period. Typically a sine wave completes its period over a span of 2 pi. But this function has been compressed by a factor of 2. It's actually been squeezed, much like you might squeeze a slinky or squeeze an accordion. And it's been squeezed by a factor of 2, so we'll divide by that factor, which means the period is now no longer 2 pi, but just pi. So it used to complete a cycle from 0 all the way out to 2 pi, but now it will complete a cycle from 0 just out to pi. The final thing we have to note is the phase shift. And the phase shift is going to be equal to pi over 2. And those values I grabbed from right here. That shifts the function left and right. But the compression also affects the phase shift. So together, the phase shift is pi over 2. And I'm going to note that that's a phase shift to the right. And you might recall that when you subtract from x, you're shifting functions right. And when you add to x, you're shifting functions left. So now we have everything we need to sketch our function. And I'm going to pull out maybe a new color, blue, and I'm going to go ahead and sketch the curve. And I'm going to do that first by doing some notating on the graph. First, I'm going to note that the midline is at y equals 1. So I'm going to sketch the midline here at y equals 1. So that's the line rather than the x-axis that's going to serve as our midline. Next, the amplitude is 3, so I'm going to go up 3 and sketch a dashed line. That's sort of my ceiling for my sine wave. And I'm also going to go down 3, down to here. And that's going to be the floor for my sine wave. Alright. Next, I'm going to sketch, or I'm going to locate where we're going to be crossing the midline. Typically, a sine wave crosses its midline right at the origin, right where it's crossing the y-axis. So typically our sine would go right there. Oops, I didn't mean to put that on. So we normally would be crossing right there. But we're shifted to the right pi over 2, so we're going to be crossing our midline right there. I'm going to note that by plotting a point right there. And then normally we complete our cycle over a span of 2 pi, but our phase shift, our period is only pi right now. So we are going to complete a cycle by the time we get to here, which is pi away. And that means we're going to go through the midline also at pi. And now I can sketch my wave. It's going to go all the way up there, all the way down, and then back. And it will continue like that forever to the right. And I can do something similar in the other direction. I know it's a span of pi, so I'm going to complete my period right there, which means I'm going to go right through here on my journey. And we're going to go all the way down, all the way up, and then start heading down again. And I'll put an arrow there to continue. So there's our sine wave.